in class. Agreed?
Mm-hmm.
Good. So we have they travel at west at 20 miles an hour and south at 15 miles an hour. And we are looking at this. And let's call it W. And then we have X and Y. So W squared equals X squared plus Y squared. And 2W dW over dt equals 2x dx over dt plus 2y dy over dt. We get rid of these 2's because they all have 2. And then dw over dt equals x dx over dt plus y times dy over dt over the square root of x squared plus y squared. We should all have this formula in a couple of minutes, correct? Would you agree so far? Okay, so now all I have to do is plug in what they say 30 minutes. But I can't plug in 30 minutes if we are talking about miles per hour. So I have to plug in half an hour, right? So then time equals 1/2 of an hour. I cannot combine minutes with miles per hour, correct? So therefore, I do have this as being 20. I do have this as being 15. Those were given in the problem. And then x will be 1/2 times 20, which is 10. And this will be 1/2 times 15, which is 7.5. And of course, this is 100 plus 7.5 squared. So I'm going to write it one more time because it's difficult to read. So for everyone to see. So dw over dt when time equals half an hour is 10 times 20 plus 7.5 times 15 over the square root of 100 plus 7.5 squared. And how much is this? Of course, in miles per hour. Okay. Now I got two 25s. It must be true. Do you want me to check with the calculator, or we all got 25 miles an hour? Yes? Good. So I would like us to continue with this. I did not show a similar problem with this one. Now is the time because of section 3.10. You will see the connection in a few minutes. So this, I'm not going to give you time to work on it because you may know how to solve it, but I'd like us to work on it together. So we are given a cost function, which is negative 0.0001 x cubed plus 0.005 x squared plus 60x and plus 800. We are told, we're asked to find the marginal cost. The marginal cost is the rate of change of cost with respect to units. So in economics, they're calling it marginal cost. So for the cost, instead of asking, they're not asking us to find the derivative, but that's what it is. They're asking us to find the marginal cost. That's okay. Just keep that in mind. The marginal cost is the derivative of the cost function. So this is negative 0.0003 x squared plus 0.01 x plus 60. This is the marginal cost. That was part A. Part B, they're asking us to evaluate it when the number of units produced is 100. We don't have a problem with that. Right? So if you want to give me the answer, I'll put it in. 58 measurement unit. It's a rate of change, so it has two measurement units, one coming from the numerator and one coming from the denominator. Since it's cost per unit, it must be dollar per unit. Now, what is extremely important is to explain its meaning. So we want to talk about that for a moment. So one explanation will be that this is the cost, the rate of change of cost with respect to time when we manufacture 100 units. The rate of change of cost with respect to time, WRT, the number of units when 100 units are produced. But what is very important here is, so the rate of change of cost with respect to the number of units when 100 units are produced. But this is what is important right now is it gives us an idea. It predicts the cost of 101st item, of the next item, in this case 101st. It predicts the cost of the 101st item. That's why it's called a marginal cost. It predicts the cost of the next item in case we decide to produce more. And that's what the third question, or the part C, is all about. Compare your answer from part B with the exact cost of producing the 101st item. So let me say one more thing before we go to part C. This is an approximation of the cost of the 101st item. It predicts. It's an estimate. It's not the actual cost of the 101st item. Now in part C, they want us to determine, is it blurry or is it me? It's a little blurry, right? Is this better? Okay, now in part C, we're asked to find the exact cost of the 101st item. How do I determine that? So let's assume we go to the store and we buy 10 pencils, but we don't know the cost of one pencil. And then the next day, tomorrow, we're going to go in and purchase 11. How will I find out the price per unit? I subtract from the cost I paid for the money I paid for 11. I subtract the cost that I paid or the money I paid for 10. And what is the difference? Would be the cost per unit. Okay, so then how do we find the exact cost of the 101st item? That's it. So let's put it in the graphing calculator. I refuse to do this with by hand. Okay, so the cost. Make sure I put in the cost, not the derivative. Okay, so the cost is negative 0.00030 zeros, right? 1 x cubed, and then plus 0.005 x squared, and then plus 60x, and then plus 800. So I go to second and table, and I punch in 101, and I punch in 100. Go and highlight. Please go up and to the right and highlight that. So this is 6807. 807.97 minus, and I think the other one, yeah, 6750. So we determined the 2. What do you expect the answer to be? You can't do that. That's not going to be any. Look again. These calculators, I don't really like them because if you're not careful, they swallow digits. Be very careful. These calculators swallow digits, according to me. So you turn it on, and it's not immediately on. And you start typing, it does not show that first digit. So I expect something close to 58. Otherwise, math doesn't make any sense. So the marginal cost is 58. It predicts the cost of 101st. So the exact cost cannot be 58. Sometimes it could. It cannot be 58, but it has to be close. What is it?
57.9.
I need 2 digits at least. 57.97.
97.
Very good. Okay, for this unit. So one more time, 58 was what was predicted. It's an estimate. And the exact cost is C of 101 minus C of 100. Did we all get the 57.97? Yes? Okay, perfect. Questions here? So keep this problem in mind because we're going to get to something very, very similar. I'm going to come back to it for a minute. Okay, next. Let's work on the last problem on the last page. Okay, 2 minutes. At what rate is soda being sucked out of the cylindrical glass? So we know how does it look, right? Area of the base times the height, that's the volume. So we're asked to, and it has a radius of 2 inches, knowing that the depth of the soda decreases at a constant rate of 0.25 inches per second. Yeah, it's we're celebrating something today, Hawaiian music or something like that.
I think it starts like 7:30 or something, but they're doing like practice.
Rehearsal? Okay.
Yeah.
Okay. So they want us to find the rate at which what changes. At what rate is soda being sucked out of the cylindrical glass that is such and such, such and such. Knowing that the depth of the soda decreases at a constant rate of 0.25. So what am I asked to find?
The rate at which the volume is decreasing.
Of course. So the question is, thank you. So the question is dV over dt. Can anyone give us the volume of a cylinder?
Pi r squared.
Very good. Pi r squared h. So then the value is the radius doesn't change. So this is 4 pi times h. So we're asked to determine how fast is the volume changing, and the rate of change of the height is constant. So what do we write?
Is that the 4 pi height? Is that the derivative of it, or?
No, I just replaced the radius by 4. I didn't differentiate it yet.
Okay.
So what do we do next?
dV over dt.
Very good. Now we differentiate. dV over dt equals 4 pi times dH over dt. And you don't have to do anything. Just multiply by 0.25. And you get pi. Measurement unit.
Inches cubed per second.
Excellent. Perfect. Okay. I think we had enough of related rates for now. For now. We'll go back to more, I promise. I would like to look at 3.10. Linear approximations. And differentials. Linear approximations and differentials. I am going to start with this. And then we go back to linear approximations. We'll have plenty of examples, and then we'll see what the linear approximation is and what it means for any function, actually. Okay. We're going back to our best friend. Here's our best friend in this course. We've seen this before. Of course, this is P. The x-coordinate is x. What will the y-coordinate be? Thank you. You can teach this now. Of course, here's Q. Very, very close, as close as possible to P. And no, it's not x plus h, but this time we're going to denote it. It's the same thing. Same idea. We're going to denote it by dx or delta x, and they are the same. Delta x equals dx. Yes, what do you think I'm going to draw next? I know you know.
Secant line.
Tangent line, indeed. Tangent line, indeed, at P. Tangent at P. Of course, I'm going to ask you to give me the coordinate, the y-coordinate of y. And you are going to say, and you have to use both. I want both. X plus dx and x plus delta x. Yes, f of x plus dx equal to f of x plus delta x, because delta x and dx are the same. Perfect. And now I would like you to tell me what this is. I will start the sentence, and you will help with it. So that's my question now. What is this? Ready?
Yes.
Ready? Okay, yes, you want to give it a shot? Yes, please. Chris, go ahead. It's okay if you're wrong.
2 epsilon.
That was cute. No. Okay, so I should have asked maybe after I give you the hint. Let me give you the hint, and then maybe you'll come up with the answer. So delta x and dx, which are the same, represent an error or minor change in x. For example, let's suppose I manufacture discs, and I make an error in the diameter or in the radius of the disc. That will trigger an error in the volume of the disc, in the area of the disc. Is that clear? Let me say that again. I manufacture discs, and I make an error. The radius must be 5 inches, but it's more than 5 inches. It's 5 point little bit. But that change, that error in the radius, will trigger an error in the area, surface area of the disc, correct? Mm-hmm. Good. So imagine now that this is the radius, and I have a minor error of dx, This function is the area of the disk. And now I would like you to tell me what this is.
Error.
Okay. This, I'm going to leave space for a moment, is the change in it's on the y-axis, so it must be a change in f of x. It's on the y-axis, it must be a change in f of x, triggered by a change in x.
X.
Question, is this the exact change? Eddie?
Isn't this the gap that was given to you that it could be within? So like if there was an error, that's the gap that there is.
No, this is the exact change. All I wanted you to say is the exact change in the function triggered by a minor change in the independent variable. Like with the example with the disk, I made an error in the radius. That error in the radius triggers an error in the area. So if the function is the area, this delta y is the exact change. So please insert the word the exact. I should have left room for it, I forgot. So delta y is the exact change in f of x triggered by a change of dx in x. Is this clear? Do we understand this concept so far? Okay, perfect. Now here's what I'm going to do next. I'm going to extend this vertical line at x plus dx to cross the tangent. I'm going to create a right triangle. And this right triangle, this is not Q here, Q is right here. So I'm going to call it P, A, and B. And I am going to look at this triangle, P, A, and B right here. And I'm going to ask you, what is this length of PB? And you will say this is, yes, indeed, delta x or dx. For this at this moment, I don't want to write delta x is the same thing, but I'm looking for dx. Then I'm going to ask you, what is the slope of this line? And remember what it is. That is the slope, the tangent line through P to the graph of the function f. So then if that's the tangent, what is the slope of this tangent? Yes, say it louder. I want the slope of this line. F prime of x, of course. There is no discussion there, right? So this must be f prime of x. Now forget about that fact. And let's suppose we have a line, and the line is PA. Can you determine the slope of that line PA in any other way? I have a triangle, so I want to determine the slope of this line. Forget about the fact that it's a tangent, forget about the derivative, just algebra, plain algebra. How will you determine the slope of this line? Rise over. We agree? Okay. For now, I don't have the name of this. I'm just going to say rise. So the slope of AP is the rise that I don't, bless you, that I don't have just yet over?
Yes.
Very good. But would you agree that these two slopes must be the same? This slope, which is f prime, has to equal that slope, which is rise over 1. Agreed? Okay, so let's set them equal to each other. So on one side I have f prime of x, and on the other side I have rise over dx. And finally, I would like you to tell me, what can this be?
dy.
Of course, there is nothing else. However, up until now, I did not disclose to you one important fact. We didn't need it. Now we do. The y at the top and the x at the bottom have meanings by themselves. All the time I told you that this is another notation, right? You can write f prime of x or you can write y over dx. But they also have separate meanings by themselves. Okay? So this is not just a notation by chance, but also dy and dx. Dx, we know what it is. We just wrote it. I don't have to write it again. I'm just going to say minor change in x. But now I want to go back to our initial drawing because now I know what this is. Can anyone identify that? We already did. When we took the triangle out, we already established that. What is it? What is this green piece? Exactly. Indeed, it's this one. So what is dy then? One other thing I want to, before you tell me what's happening here, remember, Q is very close to P, which means that this height and this height are very close to each other. From the cost function problem, whatever, what is this? Give me the number. Careful. 57, blah, 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 it's the exact. What is this? 58. So this is the exact change, C of 101 minus C of 100. And this is what we determine with C prime of 100. Since Q is very close to P, what is the relationship? And you cannot say equal, because we already noticed that they're not equal. What is the relationship between this and this? So I want us to write a relationship between delta y and dy. And then let me write the definition for dy, and then I'll wait for you to tell me a relationship between these two. Dy is the differential of y, which is not the exact difference in the function for a minor change in x, but the estimated difference, the approximate, okay? The estimate of the change in f of x triggered by dx, which is a minor change in y. So dy, why do you think it's called differential? The derivative and difference put together. Differential. They came up with a name. I have to look up that history of difference. It's a difference with using the derivative. It's not the exact difference. It's the differential. The difference with the derivative put together in one word. Okay, so what will be the relationship between these two? And you cannot say equal because they're not equal. Approximate, very good. They're approximately equal. They're not equal, and they will probably never be equal, most probably. But now, can anyone give us this formula? Let's look at what it means, and I want the formula from you. How do I determine this? We already determined it a few minutes ago. C of 101 minus C of 100. So what would you say now? Exactly. Since we are using delta y, this time we have to use delta x. So f of x plus dx minus, indeed, minus f of x. Awesome. So that's the left-hand side. F of x plus delta x minus f of x, approximately. Now, I want dy. How do I get dy? From this relationship. Can anyone solve that equation for dy for us? So dy equals f prime of x dx. Indeed. One more step, and then it will be done, and then we can work on word problems with this. F of x plus. Now, because I have dx here, I'm gonna change this into dx, but the formula for delta y is f of x plus delta x minus f of x. But since I have dx, I cannot have, they are equal, it doesn't matter. But I have to have dx in both. For consistency, they are identical anyway. So from here, I'm gonna add f of x to both sides. This is such an important relationship. You're going to see this in series. In Calc 2. It's a very important relationship. And you're going to be amazed what we can do with it. So let's look at this relationship and try to understand what it means. F of x plus a little bit of error, a little change. So f of 100 plus 1, that's the change, 1 in this case, equals the function of 100 plus the derivative of 100 times dx, which is 1. Without going back to the cost function. So f of x plus a little bit of x, a little bit of error for x, is the function plus a little bit of y. This is a little bit of y, the error triggered, the estimated error triggered by the change in x, the change in y. Okay, so here's one example, and then I'll let you choose others. Use differentials to estimate. I'll tell you where they are, and you can choose. We are looking on page 255. And here are the examples. 23, 24, 25, 26, 27, 28. And then we'll look at word problems for this. You will be astonished. You will be able to estimate e to negative 0.015. I'm assuming, and I think I'm assuming correctly, that in your wildest dreams, you could have thought or hoped to estimate e to negative 0.015. Now you can't. So let's do that one. Because now you know how and you know calculus. So let's say this is problem 24 on page 255. E to negative 0.015. So let's look at the relationship and understand what we are looking for. A lot. I'm looking for a function. I'm looking for x. I'm looking for a tiny error. And I'm looking for the derivative of the function that I consider is used here. Which function is used here? Which function? E to the? If it's a function, it's e to the? No. If it's a function, it's e to the x. This is our function. And what is its derivative? Very good. I need to establish an x, and I need to establish a dx. X has to be something very simple, and dx has to be something very close to that very simple number.
Zero.
Of course. Of course. X is 0 and dx is negative 0.015. Absolutely. That's the closest number that I can think of, integer, that I can think of close to negative 0.015. Very good. So then, this side is this. So e to negative 0.015 is approximately. Now carefully tell me what to write. Remember, I have to write f of x. Can anyone tell us what is f of x in this case? Do not calculate anything. Everyone has to see the raw form, and then we calculate.
E to x.
But we have x. Now everything is numbers. We're done with everything. We are estimated. So this, yes, awesome, plus. Now we want f prime of x. Very good. E to 0. Don't calculate anything just yet. And now we want to multiply by dx, which is negative 0.015. Good. Now this is the equal symbol. When we continue here, this is the equal symbol, not the approximate. This following is equal. How much is e to 0? How much is 1 minus this? So it's 5, 8, and 9. Would you have ever dreamt of evaluating e to negative 0.015? I don't think so. If you say yes, I will not believe you. So, e to negative 0.015. Astonishing, isn't it? But this was possible only with differentials. And it was possible because we realized that the exact change, and also the change has to be small. The change from 0 is 0.015. It's very small, right? Because if you say, evaluate this at 0.5, the approximation may not be as good. Okay? So the change is small, and we were able to use the differentials, showing that the exact this difference in the function triggered by 0.015 in any direction, plus or minus, it doesn't matter, can be estimated by f of x plus a little bit of error in y. F of x plus dy, which is f prime of x dx. Okay?
So the
Yes?
problem. Oh, okay, never mind. I think I got it.
Let's look at another before we look at word problems. What about, let's say, tangent 44? That's problem 27. Would you like to choose? Yes, Eddie, go ahead. Oh, I'm sorry. Sorry.
Did you say it always had to be an integer, or can it be a decimal depending on course?
Well, it depends if you know the answer. If you know the answer, then use it. But in this case, 0 was the closest and most convenient to work with. But is it clear, are you in agreement with me that you could have never dreamt of estimating e to negative 0.015? Would you agree? Good. Okay. So would you like to choose another, or do I choose?
You choose.
I wanted to look at tangent 44 degrees. Is that okay? Yes?
Yes.
Very good. And that is problem 20. Yes, 27 on 255. So 27 on 255, and this is tangent 44 degrees. Okay, can anyone summarize for us what are we looking for? What I recommend, write this relationship as many times as you need till it gets embedded. So f of x plus dx approximately f of x plus f prime of x dx, till this gets embedded somewhere in your memory. So what am I looking for? I'm looking for
F of x,
a function, very good. I'm looking for
F prime of x.
x that I know a lot about. I'm looking for dx, right? A minor change from what I know, and f prime of x. So what is f of x in this case? Of course. So f of x is indeed tangent x. What is f prime of x? Secant squared x. Now I need x and dx, and I'm done. I apologize for drinking so much water. I just start coughing if I don't. So what is x?
44.
Nope, I know nothing about 44.
Would you use 45?
Indeed.
Oh, and then the x is 1.
Careful,
44.
44.
careful.
1 degree.
But negative. That's okay. And I have to change it into radians. So in say again,
Why 45?
because I know everything about 45.
Okay.
Any trig function you ask me, I'll give it to you, including tangent. So we cannot, in a function, in tangent or in secant, it doesn't matter if we plug in angles, if we plug in degrees or radians. But if it's a degree outside of a trig function in calculus, no formula works for degrees. You have to change them into radians. But inside tangent and secant, it doesn't matter if you put 45 degrees or pi over 4. The answer will always be the same. So please remember that. No degrees in calc. Oops. Unless they are inside a trig function. Only radians outside of a trig function. No degrees in calc outside of trig functions. Please remember that. Okay, so now I have everything, so we're ready. The left-hand side is tangent 44, and now I'm waiting for you to tell me what to write.
I have a question.
Yes, Greg?
Why did you pick -1?
Because 45 minus 1 is 44.
Okay, I got you. The change, okay. Yeah, I got you. The minor change.
Yes. Is everyone with me?
Mhm.
Yes? Any questions? Is that okay? Everyone, please say something.
So now you do the tangent of 45.
Excellent. Then, of 45 times negative pi over 180. Anyone remembers tangent of 45? It's the only one that has sine and cosine the same. So it's 1 plus. Do we remember secant of 45? Yes, but it's squared. So it's 2, right? Because it would have been 1 over the square root of 2. Cosine, and then we flip that, so it's in, yes, very good. So this is 2 times negative pi over 180. So this is 1 minus pi over 90, or 90 minus pi over 90. You do not have to do anything else. But in case you're wondering, is this true? You should put it in. But this is all you are required to do. You don't have to approximate, do anything. So in the graphing calculator, so let's put it in. Let me put sine, I'm sorry, tangent. And since I hope, yes, it's all in radians, then I have to put pi over 4. And what we found that 90 minus pi, close the parenthesis, and divided by 90. I'm sorry, I didn't mean to put tangent pi over 4. I still have to change the mode, I'm sorry. I need 44. So tangent 44. Would you have dreamt of being able to, without a calculator, approximate tangent 44? That's how they used to do it when we got calculators. Okay, we're ready for a word problem now. Any questions? Very important relationship on what follows in Calc 2. Questions? Okay. So let's look at, since I mentioned disks and stuff, let's look at 34. The radius of a circular disk is given as 24 centimeters with a maximum error in measurement of 0.2. So 34, I'll come back, on 255. Something is 24 centimeters and something is 0.2 centimeters, and I am waiting for you patiently to identify what they are.
X.
And, of course, absolutely. So the radius of the disk is 24, and the minor change is 0.2. Okay, let's see what they want next. Use differentials to estimate the maximum error in the calculated area. So estimate. The maximum error in the calculated area of the disk. Which one is the estimate? The delta A or the dA?
Delta
DA.
Correct. Remember, the delta Y is C of 101 minus C of 100. The estimate
Gotcha.
is the differential. Remember the difference and derivative put together, differential. Okay. So what is the formula for dA? Before you say anything, remember for every function, dy is f prime of x dx. So what would be dA then? So, right, so it's going to be the derivative of the area times dx. So let's write the area now of a circular disk. Pi, since we denoted by the radius, we denoted the x, then I have to use x. Good. So can anyone give us dA? 2 pi x of course. Please do not confuse f prime with dy. They're not the same. F prime is f prime. dy is f prime of x times dx. So dA is a prime times dx. So they're not the same. dy is the differential of y, f prime of x is the derivative of the function, or the derivative of y if you want. So they're not the same. Good. So all I have to do now, write dA equals 2 pi times x, which is 24 times 0.2, and I'm done. So this is the maximum error, estimated error in the area, triggered by 0.2 error in the radius of the disk. what is the measurement unit? So you're going to give me this number. If you want to keep it exact, do not multiply by pi. So what is this? So this is 48, right? 48 times 0.2 is 9.6. 9.6 pi. You can multiply if you want to approximate it, but I'm fine with that. And what is the measurement unit? Is the error in the area? Yes, centimeter squared. Very good. Part B. What is the relative error and the percentage error? Okay. Relative error is the error over the exact. Maybe I should put better, instead of exact, I should put original. The error over the original, which means dA over A. A is the original, is the function itself, in other words, and the error is dA. Now, what I would like to write, before I put the numbers in, I would like to write 2 pi x dx divided by pi x squared. Why? You'll see in a moment why. I simplify by x, I'll simplify by pi, and I get twice dx over x. What does this mean? Because this is the relative error in x. This is the relative error in the radius. So the relative error in the area is twice the relative error in the radius. And now you can put the numbers in. 2 times 0.2 over 24, whatever that is.
.16.
0.1666?
Yeah.
Good. Once we change this into are you sure? Did I put all the zeros?
0.01.
Oh, 0.0, sorry, okay. So 0.0, okay, so this is 1.67%.
Right.
So a 0.2 centimeter error in the radius creates more than 1.5% error, relative error, and percent error, I should say, sorry, percent error in the area. So this is the relative error, and this is the percent error. Any questions? I want us to look at one more word problem. Let's see. If we can come up with something else. Let me look. Anything else? So the radius of the circle. Yeah, let's look at the edge of a cube. The edge of a cube was found to be, allow me to